Can you see my PowerPoint? Students, can you see my PowerPoint? Yeah.
We can see your screen, ma'am.
PowerPoint is there, right?
Yes, ma'am.
Okay. Okay, so let me start. Today's session is about representation of queues. It's a very simple topic. We already worked on queues data structure. We know what it is and what is the concept behind it and what are the applications of queues, right? You also know how to write or implement queues, constructing a queue, doing operations on the queue in some language, right? So same thing, we are going to look in terms of Lisp direction. How to write algorithms. Just a minute. Nitin, door. Close the door. Close the door. Thank you. Okay, so how to write a program to construct the queue and to do operations on the queue. So if you look at the operations on queue, insertion, deletion, and some concept, insertion always at the rear end and deletion always at the front end. And we also know to implement queue, we need 2 pointers. One pointer pointing to the front of the queue, another pointer pointing to the end of the queue, right? So how to implement it? So far in the Lisp language, we have worked on the list data structure. Indirectly, we worked on the pairs, right? So by using the list concept or list data structure, how to implement the queues, right? And if you visualize the diagram representation of the list, there are a set of collections of nodes, and you will have the pointer pointing to the next node and so on, right? Okay, now directly go to the Lisp way of representing queues. Okay. So the introduction in your subject, they are introducing the queues concept like this. There are mutators, setcar x, setcdr x, which are useful for constructing the data structures and for modifying the data structures, right? These are all mutators. And for constructing while constructing the data structure, we have used cons. And after constructing, we have to select something so that we have used car and CDR. And to modify, we have used setcar x and setcdr ex. Okay, so how to use the pairs to represent the data structure called queue? That is a question mark. How to use the pairs concept to represent the data structure called queue? So we also know the queue is a sequence in which items are inserted at one end, that is called as a rear end, and the deletion will happen at the front end. Okay, so if you look at here, so whenever you are defining anything, you must have a variable for that, right? So let us take the statement define queue, that is a make queue. Make queue is a function which will be making a queue, which will be empty. So how to make an empty queue? So that is one question mark. How to make an empty queue? So initially, empty queue, how it will look like? Is there any node? And how many fields? We have to go for only 2 fields, car and CDR. And what is the content of the empty queue? Both are null, right? And then after making a empty queue, I may go for inserting the data. And then here I'm inserting A and B. But if you look at the procedure, it is a mutator because exclamation is coming. So insert queue will be modifying the original queue, isn't it? So insert queue ex, that is mutator, queue A is inserted and the queue is modified so that your queue will have A. And then insert once again and the elements will be added at the end. And now I'm performing a queue deletion. Well, deletion, the deletion will happen at the front and again is a mutator. It is modifying the queue. After deletion, the originality will be changed, right? The original queue content will be changed. So it is a mutator. So delete queue exclamation and then insert queue so that BC, CB, CD, and then I am deleting. So B is deleted. We have a CD. So these are all the sequence of operations. So in terms of a Lisp data structure, we must use the mutator. Every time you are inserting, every time you are deleting the data, you have to use the mutator. Why? Because the original queue will be modified. Okay, so these are the operations we are going to perform. So how to write the procedure for these operations? Okay, there is a content. Okay, so now let us analyze the queue operations, set of operations what we can perform on the queue. One is a constructor. Constructor, what it will do, it will make a queue and it returns an empty queue. Okay, that means the queue will not have any item, but it will have some structure. Okay, and what does I want? I want two selectors. That is empty queue question mark. Given the queue, I will apply the procedure empty queue question mark, which will test the queue whether it has item or not, whether it is empty or not. It will return you true or false, right? And then front queue of queue, it returns the object at the front of the queue. Okay, front queue is a procedure we have to write. Okay, and this front queue will return an item if there is an item in the queue. If it is empty, it has to throw a error. It is empty. You are performing a selection operation where there are no elements. Okay, so this front queue will not modify the queue. So it is not a mutator. It is a normal function. And empty queue also normal function. So these are all the selectors. Okay, and then what else we need? We also need two mutators, insert queue X and delete queue X. If you look at insert queue, you have to take two parameters. One is in which queue, the queue data structure, and then the item to be inserted. So it will insert an item at the rear end of the queue and it will return the modified queue. It will return the modified queue. Delete queue for which only one parameter, in which queue you want to perform a deletion operation. It removes the item at the front of the queue and it returns the modified queue. And if it is empty, okay, whenever you are writing a procedure or mutator, you have to take care of all the cases. If there are no items in the queue, how can you delete? So in that case, your procedure has to signal an error. Okay, so the two mutators are needed. So one constructor is required, two selectors are required, and two mutators are required. So now let's look at how to implement the queue using the list structure. For the queue, we need a front pointer and a rear pointer, and front pointer always point to the first data, and rear pointer has to point to the last data. So now by seeing within a second, you can understand, oh, this is the queue. Given the diagram, visually your mind is interpreting, yeah, this is a queue, this is the way we can interpret, right? So in this queue, Q is the variable, okay, which represents the whole queue, and in which there are items A, B, C, and this cons, the car part of the cons, this root item, the root node has a pointer pointing to the first data, and the CDR part is pointing to the last node. Okay, so now we have to make this construction through program. So what is that? This car part of Q should be taken as a front pointer. You have to name it. And CDR part of Q, you have to name it as a rear pointer. Isn't it? Otherwise, nothing, no speciality here, isn't it? We know how the list will be constructed, and here how to visualize the queue using the available data structure, right? This is the way. Right now, you can able to assume how the empty list will look like. You tell me how the empty list will look like. Sorry, empty queue will look like. there are no items here. Okay, so there is no front pointer, there is no rear pointer, right? And the car part of Q will be null, and the CDR part of Q will be null. So that front pointer is also null, rear pointer is also null. Yeah. So these are all the statements we have to make when you're constructing the queue. Okay, so while constructing a queue, you will take a pair, and the car part is null, and the CDR part is null, and the front pointer is car of Q, and the rear pointer is CDR of Q, and indirectly both are null after that, isn't it? So now, with this visualization, let us try to write some of the procedures, a higher level procedures, which will be built with the help of lower level procedures. So now you just look at the lower level procedures, what we require for achieving higher level procedures. The higher level procedures, what we are going to discuss is insert queue, delete queue, isn't it? Insert an item, deleting an item from a queue. For these things, we require a small procedures. Okay, let's look at what are they. Define friend pointer. Friend pointer, define friend pointer queue. So is it a function? What is a function name? And the friend pointer is a function, right? Which will return you always the car of queue. Friend pointer of Q. So what is that? Friend pointer of Q is a function which will return you the car of Q. Okay, whether it is null or it is pointing to the first element, isn't it? Okay, you just look at it, then we will come back once again in detail. Then there is a procedure rear pointer. Rear pointer Q is always returning CDR of Q. So that means it will return the CDR part. From this, we can able to understand the rear pointer and front pointer. Okay. Now, if you look at this mutatas are set front pointer, given the queue and item. You're going to modify the queue. What is set car X will do? Set car X will do, what is that? Given that particular item, it will modify the car part. Likewise for the CDR part. So now if you take this set car X Q item, so what you're doing, Q is something, it may be a list, right? Or it may be a pair consider cons, and in which the car part is modified with this item. Isn't it? So this task is done through the procedure set friend pointer X. Set friend pointer X, for which we are passing two arguments. One is the queue and the item to be inserted. Okay. So here the set friend pointer, what it does, it is always assigning the car part of queue to item. Right? Then likewise, in the opposite side, set rear pointer X, for which Q and item is given, and what it does, set CDR exclamation Q item. So the CDR part of Q will be modified with item. So this is a simple thing. This is a selector, right? It will give you the car part of Q, and this function will give you the CDR part of Q. And this function, what it does, set front pointer, it will modify the car part of the queue. This will modify the CDR part of the queue. Okay, so these lower level functions are available. With this, we will do something. Yeah. So now the first function, what we are going to do is we are just going for investigating whether the queue is empty or not. Whether the queue is empty or not. So how to check? So I'm going to define a procedure empty queue.
Ma'am,
Yeah. Just a minute.
these are mutators.
Which one?
Set car and set CD are like they are inbuilt, no, ma'am.
Yeah, these are mutators we have studied already, right? Yeah.
Ma'am. Is the racket software supporting it because mine is giving errors?
That one you're using Racket, right? In some other
Yes,
version of this, it must be. but we are not, your theory is not focusing on the racket. So assumption, we will just check it out in which version it is supported. We will check it out later. Okay, in the next session. Yeah. Okay. So we are going to define MTQ question mark procedure. MTQ, given a queue, whether it is empty or not. What you will do? The front pointer of the queue. Okay, front PTR of queue. Front PTR is the function which will return your car part. Right. So the car part of a queue is null or not, it is checking. If it is true, then it is empty. If it is false, it is not empty. Yeah, you just listen once again. Define empty queue procedure given the queue. What it is, the front pointer of the queue is null or not. Front pointer queue is going to call this function where the car of queue is returned. Okay, so car of q can be a null value or it can be pointing to some other node. Okay, so this is car of q is pointing to some other node. If it is not null, it is not empty, right? So that is what. So we are checking it is null or not. It will return you true or false. Okay, this is over. Now let's go for another thing. How to construct a queue. So we have a make queue procedure. Make queue procedure, while making, what is that? It is a default node, right? Default is a empty node. Okay, so make queue is nothing but cons of car part is null and CDR part is null. So make queue, what it will do? You are taking a cons part and this is null and CDR is also null. Okay, so these two procedures are understandable, right? So empty queue and then make queue. Okay. The next we move on to that is front queue. That is selecting an item at the front of the queue. What is there in the front of the queue? I would like to return that value. So what you have to do? You are going to define a procedure front queue. Front queue, given the queue, that is this queue, given, consider this diagram, you have to retrieve the element. Okay, which is, what is the one? The front pointer, what the front pointer is pointing. Okay, that one you have to retrieve. That is, A should be the answer. So how the procedure goes? It goes like this. Define front queue function name and then the queue is given. It is empty or not, first of all you have to check, because you are going to call the front queue immediately after the make queue. Consider, okay, consider immediately after making a queue, you are calling the front queue. Then if it is empty, it will give you a error. Otherwise you are calling the front pointer of queue. Front pointer of queue, what it does, it will return you the car part. So what is the car part? Car part is pointing to this one, isn't it? And in that part, only the car part. So car of q. Understood, right? Front pointer q, if you look at the procedure, front pointer q, it is returning car of q. So here the car of q is what? A pointer pointing to this one. In this is referring this one. In this, what is the car? Car is A. Okay, so car of q. Okay, I hope you understood. This is for selecting the front element in the queue. Any doubt in this? Let's move on. Now, let us go for writing the higher level procedure. Insert QX is a mutator we are going to write. So insert mutator, you just look at and can you be able to understand? Can you understand? I just copy it. Okay, I have to insert an item. I'm calling this mutator insert QX, Q, and then some item. So what you will do? The insertion will happen at the rear point, isn't it? So I'm going to insert a node. Insert Q item in which, what are you doing? Just a minute. Okay. Let new pair is cons item. Cons item. Cons, you are constructing an item. Okay. And assign to a new pair. First task is you have to get a new node. You are calling the cons. And this is nothing but now, this is what? New pair according to the procedure. It is new pair. Consider I am writing new. Okay, so in the pair, if you look at cons item and then the something is null. Okay, that is cons item. Item is a car part. For example, I want to insert 2. Okay, 2 is the item. And then this is null. Okay, so you are making cons. And then you are assigning to a variable new pair. So consider it is new. I have written it is in a shorter way. Okay, this is over. Condition empty queue of queue. The queue you are investigating whether it is empty or not. It is not empty, consider, or it is empty. Let us consider. If it is empty, what you have to do? Otherwise, what you have to do? So there are two parts. So if it is empty, what are the things you have to make? So what is the thing you have to make? The front pointer should point to the new node and CTR pointer should also point to the new node. Okay, so you are just modifying the value of the car part and the CTR part, isn't it? So that there is a mutator. So the mutator at the front pointer and at the rear pointer. Set front pointer, okay, you are calling set front pointer X, Q and the new pair. Given the Q and given the new pair, you are calling the set front pointer. Okay, so let's go for set front pointer, what it does. Set front pointer mutator, what it does. Set car, you can see here, set front pointer, what it does. It is modifying the car part. Okay, it is replacing the car part of Q with the item, isn't it? So same thing we will apply here. Car part of the queue is to be modified with an item, that is this new one, isn't it? So you have to assign this to the car part, isn't it? And then set rear pointer is q new pair, because see, new pair is only one node. This address is assigned to both front pointer and rear pointer. Yeah, can you understand this part? And then returning the queue. The whole queue will be returned. So I hope this condition you can understand. If the queue is empty, what is happening? If the queue is empty, after taking a new node, the new node address is known. That is what? New pair. And you have to assign the car part to the new pair and then CDR part also to the new pair. That's what we are doing here. Understood? So set front pointer of a queue to new pointer, new pair. Yeah.
Generally, in the syntax of a condition cond, we will be uh, giving one condition, and if that satisfies, what will be happening will be given, ma'am. Like here, I can see three things within a single part. Like generally, it is only two, no, ma'am. Like if it is empty of Q, then we will be doing only one thing.
See the
Why
bracket
it is?
actually. Bracket actually.
Yeah, bracket. Where
This
is
is
it
closing
closing?
here.
Like.
You never done like this? More than one statement? More than one action you never done?
No, ma'am.
Yeah, that is why this is also possible.
What
Okay,
exactly
so
is happening, ma'am? Like, can you
okay,
explain
so
once
this
again how
is okay.
cond is happening?
Cond bracket. So first bracket is what? First bracket is condition. This condition q is empty. Then what you are doing? Set front pointer, set rear pointer, and then returning your q so that this cond true part is over. And then first part you have a else, cond else. Else part is if it is not empty, we are going to do this one. Cond is you never done this type.
Ma'am, actually, how for the begin and something is there, no, ma'am, for block statements. Like that time, inside the if we use something like I forgot the what we did like exactly. But
Okay,
then
okay.
that
You
time
just
we applied
have
conditional
assumption.
condition.
You have assumption
Yes,
like
ma'am.
this.
Yes.
So you have a condials and inside a cont, if it is true, obviously the language has to provide a flexibility
But
that we
generally,
have
instead of
to.
returning only
Mhm.
Q, we are setting it, ma'am. The set, I think in the transaction bank and all, ma'am explained this syntax. I understood, ma'am, what happened. Thank you. Like,
Okay,
I will
okay,
refer
okay.
the slides.
Yeah. Okay. Okay. So I hope you understood the empty part. The queue is empty. The two assignments we have to do. Okay. Let's go for the else part. If the queue is not empty, what we are going to do? If the queue is not empty, what you are going to do? So what I will do, consider I just draw. Insertion will happen at the rear part, isn't it? So I'm just drawing once again. So now this is new. I'm not using mouse. Okay, consider this is new now. And I'm going to insert the same value to, okay, for simplicity, you take 3, okay, right. So now the queue is not empty, we have to insert. What are the actions you have to perform? Is there any modification you have to do it in the front pointer in terms of front? Front pointer, you no need to disturb. You have to disturb only the rear pointer. So now what are the activities? There are two things. One is the last node should point to the new node. And then this front pointer, now it should point to the new node. These two things we have to perform. Isn't it? Yes or no? Yes or no?
Yes,
Taking
ma'am.
a new node, you have to the already existing list in which the last node should point to new node and then the PTR has to be pointing to the new node. These two things you have to do.
One small word. Like,
Yeah, yeah.
initially, when we were defining, we haven't put the exclamation mark as far as I remember. The set friend PTR and then set real PTR. We have to use the same syntax, no, ma'am. So while defining itself, we should have put exclamation mark, no, ma'am, for the set friend PTR and set real PTR.
I'm not understanding what you're asking. Oh, set
In the
serial.
definition part, when we
Ah,
were defining it, like we haven't used the exclamation mark. We directly put set friend as far as I remember. Like there was no exclamation mark.
yeah,
Can you just
see.
go back and check?
Yeah, this is the one, no? Can you see?
Not this one, ma'am. Set one. Set one was initial. Oh, oh, okay, okay. I haven't noted it down.
Yeah.
Okay, ma'am.
So now what we are doing is rear pointer of Q. Rear pointer of Q, if you look at the procedure, rear pointer of Q, what it is returning the CDR part of Q. Okay. And then, uh, what you're doing is that the CDR part is the CDR part of that one is modified to a new pair and then set rear pointer Q new pair. You just look at everything if I'm explaining what will happen. Yeah, please understand. I just pictorially I have told you two things, two assignments you have to do. So can you understand this code? Can you understand this code? What is the first assignment we are doing? Rear pointer of Q. Rear pointer of Q is what? This is pointing to this node. So you are getting the address of this. And then the CDR part of that, CDR part of is null now, isn't it? This null, actually, you have to replace the CDR with a new so that there is a link. Understood? Rear pointer of Q is now you are getting the address of the last one. In that, the CDR part for which you are going to assign something so that you are calling the CDR mutator. So for this, what you are assigning, that is new node, address of the new node. That is what you are replacing the CDR part of this queue, this rear pointer of the queue to new pair. Getting it? Rear pointer of Q, which will return you CDR of Q. What is CDR of Q? Q is here. CDR part is what? It is pointing to this node because it is not empty. And in this node, we have to go to CDR part. In that, you have to assign the address of the new node. That means it is a mutator. Which mutator you have to call? Set CDR. Set CDR. Okay. Set CDR. Okay, and you reached, because of this, you reached the rear pointer, the last node address. And the last node address, in that, the CDR part has to be assigned to new pair so that there is a link. The second statement, look at. Second statement is set rear pointer of Q new pair. What will happen? Set rear pointer mutator. What it does? Let's go back. Set rear pointer mutator. What it does? It will change the CDR part of the queue to item, isn't it? You're changing the CDR part of the queue. Okay. So Q is this one, and the CDR part is this one, for which what you are assigning? You are assigning what? New pair. So address of the new pair. So now after this statement, there is a connection to this. Very simple. Look at. Do you understand anyone apart from Priya? Anyone is there online? For only one student we are teaching, very pathetic. Our life is like that. Yeah, some gents voice I can hear.
Ma'am, actually, I have a small confusion. Generally, the theory part I understood. Like we have to insert the element to the last, and then we have to give the pointer. Like we have to change the rate pointer to one element ahead, no, ma'am. So that is what this set rate pointer used to must be doing. But then, what actually set rate pointer does is it sets the CDR of the queue to the item. But then the CDR of the queue should be from second element onwards, no, ma'am. Like what is
CDR, see,
happening?
this
Like
is no, no, no,
RHP
no, no. The Q is pointing here. What is the CDR part? This is the one.
the diagram, yes, yes, yes. Now I
Yeah.
understood. Okay,
Okay.
the
So,
links are like this, and then yeah. Now makes sense. Also, ma'am, the brackets. If I mm, uh, if you check the last brackets after Q, the bracket
yes.
coming is
So,
closing, and then the second one is closing cond, and
mm,
the third one is closing defined, ma'am. Why is the fourth closing bracket
let
coming?
let we are not closing it. No.
Okay, yeah, making sense. Yeah. I closed let initially only. Inside the let only all this comes.
Yeah.
No, yeah,
Yeah.
fine.
Okay.
Yeah, yes, thank you.
Okay. So, any boy side, do you have any concern? Can you understand at least one example? Mm. students? Anyone else understanding?
Yes, ma'am.
Who is that? What's the name?
Vishnu, ma'am.
Okay. So shall I go ahead? No problem with this, right?
No.
Now, let's go for deletion. We are going for writing the deletion mutator, delete mutator. So simply what you have to do, you have to move the pointer, front pointer to the next item, isn't it? So, but there are two cases. The queue is empty or the queue is not empty. If queue is empty, you just raise an error exception. Otherwise, you have to just move the front pointer to this one. How will you do? How will you refer the second pointer? This front pointer should point to the second item. How will you refer? Initially,
The CADR of like basically what we can I speak, ma'am?
yeah,
So basically, generally, we have to set the front PTR to the B, no, ma'am. So how is B related to the Q? B is not directly associated with the Q. So I thought we can do the so CDR. If we do means we will get
yes, yes,
CDR of A. We will do means we will get from BCD, no, ma'am. If we again put a to it, we will be getting the B element.
yes,
Something like
yes,
that, ma'am. I
yeah.
actually got little confused.
Okay, so what is the car part of Q? Car part of Q is a front pointer. That means it's the address of this node. In that we have to refer the CDR part. Okay, let's look at. Okay, how to delete the queue? Condition empty queue, raise an exception. Otherwise, go to the else part. Set front pointer. Here you have to be very careful. Set front pointer. You are applying the mutator for the front pointer in the queue. Given the queue, what you are doing? CDR of front pointer and then queue. Okay, so you just take the internal thing. So front pointer of Q, which will return the car of Q. Yes, this will return you car of Q. If you look at the previous procedure, preliminary procedure, car of Q. So and then CDR of car. And then CDR of car. So if you look at here, this is returning the car part so that we are getting the address of this one, and then the CDR is getting the address of this one. So that is nothing but what we are going to assign to the car part of Q. Okay. So how to assign to the car part of Q? Set front pointer, which will assign something to the car part, right? So set front pointer given the Q. Then what you are assigning now the item is CDR of car of Q. CDR of car of Q is assigned to the car part of Q. To the car part of Q. That's what very simple, right? So what we did to this field, we are assigning what car of will refer this one, and then CDR will refer this one. So CDR of car of this front pointer will be assigned to the car of Q. Okay. As per your expectation, same thing we have written. Okay. So this much if you are understanding, then we can go for NQ, DQ, performing addition, deletion at the both ends. Always we can do. Okay, so in today's session, we were talking about the queue implementation and the working of queue implementation, and then the functions required for implementing the queue. We need a constructor, that means which will be useful for making a queue with the empty data, and then two selectors, whether it is empty or not, or what is the front of the queue, and then two mutators, insert queue and delete queue, which will insert an item at the rear point, which will delete the item in the front point. So we illustrated how the queue will look like if we are using the list structure, and then we went on to explaining the higher level procedure that is returning insert queue mutator and delete queue mutator. Okay, this is what. So nice, no? If you are understanding, everything is simple. If you are not having interest on listening to the class, everything waste. You are wasting your time. Again, you have to invest time for understanding, and again, you will not understand, and then exam will come. Then you will write something else.
Ma'am, in the exam, a written will be there, no, ma'am. Offline means we will be asked to write the codes, or like how can we expect the pattern to be? Like after midsem, everything is like complex numbers, bank, everything is like code only, no, ma'am. It's like kind of except the box, whatever we environment variables, boxes and all we do. Except everything is like we are
So
building
100 marks,
something.
for 100 marks we have to take. For 100 marks it
Oh,
is very difficult. So 3 hours you have to sit and write the whole subject. You should be
ma'am.
you should thorough in
Uh,
fingertips.
2 hours or 3 hours, ma'am?
3 hours.
3 hours. Ma'am.
Mhm.
Okay, isn't it reduced because of
Yeah.
like is
Now
have you received the instructions that it is 3 hours only, or is it yet to be decided?
no 3 hours. Decided.
Oh, all subjects.
The students will have a trouble now. From the beginning, you have to read whatever you have copied in online. You have to read. Okay.
Okay, yes, ma'am. So we can be asked to write the codes, or like
Writing code and concepts and then partial code, everything, all mix and match.
okay.
So, where to concentrate and all, don't ask everything, you have to concentrate from the beginning till the end. Okay, particularly you try to go for doing the exercises, and there is a solution available for all the exercises. So you just Google it, SICP, Structure and Interpretation of Programming Languages. You just say solutions and something, there is a PDF coming. For all the exercises, they are giving answers.
Exercises from where, ma'am? Textbook.
No, in the textbook, there are exercises, no? In the textbook itself.
Oh, textbook I have. It's in the files, ma'am. I think
Oh,
I will
yeah.
check sometime.
Yeah, tell me, otherwise, I give the book. And in the next,
Yes,
the
ma'am.
book is
Just one
available.
minute, ma'am. I will check right away.
Mm. The PDF, the book PDF is there, and the solution PDF is also there, I think. Or online itself, there are many universities they are providing the answers.
Oh, I don't see. Yeah, I see, ma'am. Textbook is there. July 15th, SSCP
Oh,
textbook.pdf.
so far you never opened the book.
Ye-
Oh my God, that's why the people are asking for a PPT. I'm just surprised. We are copying from the textbook only. Okay.
Okay, ma'am. Thank you so much.
Thank you. Thank you. See you. Bye. See you in the next session.
Yes, ma'am.
Okay.